For geometry 2.6, we're still proving things, and today we're going to prove angles are congruent. So number 1 says, first find the value of each variable. To start, identify the relationship between the marked angles in the diagram. So this angle's marked and this angle's marked. Sorry, this angle's marked and this angle's marked. So what is the relationship between these two? They are, I hope you remember this vocab word, they are vertical angles. They are vertical angles. Then write an equation to express this. Well, if you know that vertical angles are congruent, then you know that this angle equals this angle. So that would be 68 minus x equals 3x. Okay, so now we're going to find the value of each variable. So I don't think we needed to find that. Oh, yeah, we do. Yeah, we do. So if you know, I'm going to make room over here. So if we know that 68 minus x equals 3x, we are just going to solve it. It doesn't say to write a proof for it, so I'm just going to add x to both sides. That would be 68 divided by 4, which is, I don't know, 68 divided by 4 is 17. So x equals 17. So that is how to do this. Oh, and it already has the answer there. Are you kidding me? I'm sorry. But now we know how to do it. Okay, number 2, we need to find the variable y. Interesting. Oh, and we need to find the variable x as well. Well, what I know is that this is vertical with this, and vertical angles are equal to each other. So I'm going to set them equal to each other. So 10x minus 18 has to equal 8x plus 14. All right, so I'm going to start by subtracting 8x from both sides. You don't have to start with this. That's just what I decided to do. I'm going to add 18 to both sides. 2x equals, what is that, 32 maybe? Yes, divide both sides by 2. X equals, is that 16? I think it's 16. So x equals 16. So here's the deal. If x equals 16, here's what we know. We know that we can go ahead and plug in 16 for either one of these. It doesn't matter, this one or this one. So what is 8 times 16 plus 14? So let's find out how many degrees this big angle is. So 8 times 16 equals plus 14. Remember, you have to do order of operations. So 142. So this big angle is 142 degrees. And what I see is that this big angle is supplementary, or a linear pair with this line. So 142 plus question mark would be our y, would equal, 180, because a linear pair adds up to 180. So I'm going to do 180 minus 142, which is 38. So this little angle over here, which is y, has to be 38. Okay. Number 3 is exactly like number 2. If you want to, I would try that out, and you can make sure you understand how to do that. But since these are the same, I'm going to move on. Let's see what it says. Find the measures of the labeled angles in each exercise. Oh, they're talking about down here, I think. Let's make sure that that's right. Oh no, must have been up here. I don't know. Find the measures of the labeled angles in each exercise. Didn't we already find them? Exercise 1 was... Oh, we only found what x was. It was 17. We didn't find the labeled. So 3 times 17 is what I guess they're asking here. So 3 times, since x is 17. So 3 times 17. I mean, this is just more of the same stuff. It's practice with algebra and practice knowing that vertical angles are congruent. Linear pairs add up to 180. So that's 51. So the angle measures 51 degrees up here. Both of these would, since they're vertical. exercise 2. I think we got them all. We got 142 and 38. 142 and 38. These were both 51. And then we didn't do exercise 3. If you want the extra practice, go for it. But this should be pretty clear. All right, let's then go down and do a proof. So you're given that angle 1 is congruent to angle 2. So I would start by making little arcs on angle 1 and angle 2, because the more you mark up this diagram, the more it's going to help you figure out how to get from 1 to 8. So these two are congruent. Angle 1 is congruent to angle 2, that's given. We need to try to prove that all the way down here, angle 4 is congruent to angle 3, or angle 3 is congruent to angle 4. So we want to prove these two. Okay, so here is what we're looking at. They did angle 1 plus the measure of angle 3 plus the measure of angle 5 equals 180. Measure of angle 1 plus 3 plus 5. They did a linear pair equals one, or sorry, more than a pair. They did supplementary angles equal 180. So what they did was they added them all together. So you're looking for clues. If they added this angle, they added this angle, they added this angle, and it equals 180. What they did first is they did an angle addition postulate. Angle addition postulate. Next they did angle 1 plus angle 3 plus 90 equals 80. So they substituted angle 5 for 90 degrees because they know it's marked up. So this would be substitution. Then they moved on and said angle 1 plus angle 3 equals 90. So looks like they went from 180 and they moved the 90, they subtracted it from both sides. So this is subtraction. Okay, then they have measure of angle 4 plus the measure of angle 2 equals the measure of angle 5. So let's look at 4 and 2. 4 plus 2, sorry. They did angle 4 plus angle 2. So these two together equal the measure of angle 5. So what's the relationship between these? 4 plus 2 equals 5. These two are vertical angles. Sorry, these two added together equal this vertical angle. So number 5 is actually definition of vertical angles. Or actually, this would also be vertical angles theorem. Whatever. If it says definition of vertical or vertical angles theorem, that's totally fine. All right, number 6, then what did they do? They have these same numbers. The measure of angle 4 plus the measure of angle 2, again, has to equal 90. So once again, if 5 equals 90, then they're switching it around here. Now this one equals 90, so what they did was they substituted 90 for the measure of angle 5. So they substituted again. Substitution. Okay, and then they went on and said measure of angle 4 plus, now they changed it from 2 to 1. The measure of angle 1 equals 90. So that would actually be substitution again. We're substituting, we're flip-flopping them. We're substituting angle 1 for angle 2. I'm sorry, angle 2 for angle 1. So substitution again. And then in the very last step, you're ready to prove it. Angle 4 equals the measure of angle 3. And here's what this equals. You guys, this would be in a word bank, but this would be called congruent complements theorem. Okay, so let me make sure you guys know what that would even mean. So if they're complementary, that means they add up to 90, which we were proving this whole time. Then they are congruent. If they are congruent complements of each other, then that would mean they add up to 90. Okay. Angle A and angle B are adjacent complementary. Adjacent, remember, means right next to each other, so it would be like this. They add up to 90 and they're right next to each other. Angle C is supplementary to the angle formed by A and B. So angle C would be like right here. And it is supplementary. Okay, think about what that means. They add up to 180. What can you conclude about angle C? So I hope that when you drew this picture, it helped you see that angle C would also be a 90-degree angle. So it is a right angle. And the reason is, I mean, really, substitution. You can, well, okay, let me just write this out. The measure of angle A plus the measure of angle B equals 90, because we know that that's by definition of complementary angles. And then the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. That is by definition of supplementary angles. And then what you could do is you could just substitute the 90 for this and then subtract it. So really it's subtraction property. That would be why, that would be why the measure of angle C equals 90 degrees. Okay, we're not going to do all of these on the back because I know that you guys probably are starting to get this. As long as you have a word bank, I would think you'd be okay. But let's do just a few real quick. Angle 1 and angle 4. Sorry, if we did a proof and we're really just filling in some blanks here. So this is angle 1 is congruent to angle 4 because it's given. So angle 1 is congruent to angle 4. It's given. Angle 1 is congruent to angle 2 by, what's that relationship? By vertical angles. Vertical angles theorem. Angle 2 is congruent to angle 4 by transitive. 1 equals 2, 2 equals 4 because 1 equals 4. So that's kind of like that syllogism stuff. So transitive. And then angle 3 is congruent to angle 4 by the, let's look at 3 and 4. 3 and 4 are also, look at that relationship, vertical. Vertical angles. And so it follows that what we're trying to prove, angle 2 is congruent to angle 3. Angle 2 is congruent to angle 3 by the transitive, because that's what we did. We just moved them all around. Transitive property. Transitive property of congruence, whatever. Okay, numbers 10 and 11 are more just practice. I think if you know that they're vertical, you'll set them equal to each other, you'll solve. I don't need to work all of that out with you. Same thing here, you would set either these two equal to each other, or you could set this one plus this one equal to 180, because you know that they are a linear pair. So if you need a little extra practice with that, try those and we can check your answers later, but that's how to do them. When you get down to number 12, name 2 pairs of congruent angles. Well, I would just name the 2 vertical angles. So angle WQY and angle ZQX, or XQZ, WQY, yeah. So vertical angles are congruent. That's your 2 pairs. Oh, 2 pairs, that's 1 pair. The other one would be the other direction. So these big obtuse ones, XQY and WQZ. 13, 2 pairs. Oh my goodness, there's actually lots of options here. So you could do these 2 because they're given, because they're marked up given. So AGC and EHD because they're marked up. Or you could do this one with this one because it's vertical. You could do this one and this one because they're vertical. You could do this one and this one. Same thing, this one and this one. So vertical angles are really good to know. All right, down to number 14. Angle A is 3 times as large as its complement, angle B. So let's just make sure you would know how to set that up. Angle A, let's just say, oh, it's complement. You know that complement's going to be 90 degrees. So let's say angle A, is 3 times as large. This is going to be A. Angle A is 3 times as large as angle B. So we don't know what angle A is. We can just call it X but we know it's 3 times bigger than b, so we're going to call a 3x plus b only represents one of the x's, but it equals a total of 90 degrees. So 3 times bigger than the original one equals 90 because of the word complement. So you would solve all that, find each angle measure. Angle A is 21 less than twice as large as its supplement. So I would start by saying its supplement is equal to 180. Angle A is 21 less than twice as large as its supplement. So what we're looking at there is, here's your straight line, because it's the supplement. Angle A is 21 less than twice as large. So twice as large minus 21 as its supplement. So you would add those up, 21 less than twice, whatever the other one was. So you would have 2x minus 21 plus x equals 180. And then you would solve it. And then you would get both angles. Both of these are asking for both angles. I'm just going a little quickly because I'm just wanting you to practice being able to set it up. I'm sure you're going to do the algebra well and solve it correctly. Number 16, angle A is congruent to its supplement, angle B. So, that really just basically told you the answer. Its supplement means they add up to 180, but if they're congruent, they both have to be the same. So each one would be 90. Okay, and then the last one, angle A is 18 more than 5 times its complement. Complements add up to 90. So if you picture it, 18 more than 5 times, and then plus 18, its complement. So 5x plus 18 plus the other one equals 90. Solve it, get both angles. There's your algebra practice for today.